Geometric probability. So geometric probability is basically desired area divided by total area. And remember that probability is always a number between 0 and 1. It can be represented as a fraction, decimal, or percent. So let's think back to our area formulas in geometry. Rectangles length times width. Area of a square is side squared. Triangle is half base times height. And circle is pi r squared. Number 1. A dartboard is shown in the diagram below. The two lines intersect at the center of the circle, and the central angle in sector 2 measures 2 pi over 3. Let's label that, and we know based on vertical angles, sector 4 has angle 2 pi over 3 radians. If darts thrown at this board are equally likely to land anywhere on the board, what is the probability that a dart that hits the board will land in either sector 1 or sector 3? So we know that because a half a circle is pi radians, if this is 2 pi over 3 radians, this is 1 pi over 3, or pi over 3. And vertical angles, this is the same thing, pi over 3. Now normally we would compute the area, desired area divided by total area, to find the probability of 1 and 3 out of the entire circle. However, since the measure of each sector's angle is in proportion to the area of the sector, we only need to use the given angles. So basically we're going to add this angle to this angle divided by all the angles in the full circle. Now I'm not using degrees, obviously, we're using radians. So the formula is sector 1 plus sector 3 divided by the angles of the measure of the entire circle. So we have pi over 3 plus pi over 3 all divided by 2 pi. Pi over 3 plus pi over 3 is 2 pi over 3. 2 pi is still there. And we must remember that this is a keep change flip situation. 2 pi over 3 times 1 over 2 pi. The 2 pi's cancel out, and the answer is 1/3. So the probability of hitting sector 1 or sector 3 out of the full circle is 1 out of 3. Number 2, here is your Regent style question, or SAT style question, where you have two quantities. Answer choice A, the quantities are equal, or sorry, A is greater. Answer choice B says quantity B is greater. C says the quantities are equal, and D you cannot determine based on the information supplied. So once again, we have two different dartboards. This one's square with a circular bullseye, and this one's a circular dartboard with a square bullseye. So we want to find out what the probability is for each one of these and compare the two. What's the probability of hitting the target area? Column A, area of circle divided by area of the square. That is your desired area divided by the total area. Column B is different because the shape is square divided by circle. So let's go ahead and replace these shapes with the area formulas. And here we have pi r squared over s squared. And we'll go ahead and replace the variables with the values. The radius is 2, so we have pi 2 squared over 10 squared, which is the area of a square. And this gives us 4 pi over 100. We'll reduce the fraction, and we end up with pi over 25. Now looking at column B, it's s squared over pi r squared. Replace the values, and we end up with 4 over 100 pi. Reduce that fraction, we end up with 1 over 25 pi. So basically, the question is, which probability is greater, pi over 25 or 1 over 25 pi? Now, if you think to yourself, if you throw darts at this dartboard and only hit the bullseye around 3 times for 25 attempts, that's your probability, 3 out of 25. But over here, 25 times pi is about 75, and out of 75 attempts, we're only hitting the target once. So obviously the answer is greater than. So we know that the answer is A. For those people that need the calculator to spell it out for you, let's go ahead and do that. Pi over 25 is 0.125666. 1 divided by 25 pi, you must use a parentheses. If you don't use parentheses, you'll end up with the exact same decimal approximation, and you'll put down C, and that's wrong. So if you use parentheses properly, you end up with this, and obviously this is the greater probability. Sage and scribe number 1. So here's another dartboard, and we have two circles. The first circle is x squared plus y squared equals 25. We know that the center of the circle is 0, 0. And the radius is 5. So there it is. We'll draw the circle centered at the origin with radius 5. This circle over here is centered at 8, negative 6. And this radius is 2, so it's much smaller. And there it is. Circle M, circle V. What is the probability that when you play this game, you hit a point that lies outside of both circle V and circle M? So one more time, you have to ask yourself, it's desired area divided by total area. So the way we get the desired area is by finding the area of the entire square, which is 20 units by 20 units, by the way, and then subtract out the area of both circles. So here's my symbolic formula. It's square minus big circle minus small circle, all divided by square again. Sorry, this looks like a rectangle, but that's supposed to be a square. So the area of the square is 20 squared. So it's 20 squared minus 25 pi, because the radius, remember, is 5. So pi r squared, that's 25 pi. And the smaller circle is 4 pi. Carefully put this in your calculator. Don't forget to put parentheses around the numerator. And we end up with this result right here. So the probability of hitting an area outside of both of these circles is about 77%. Sage and scribe number 2. So here, it's interesting. You have 6 unopened cans. You win a prize if you drop a ball and it falls between the cans into the box. What is the probability you will win a prize? Would your chances improve with more or fewer cans packed in the same way? Let's only answer the question about the probability. So the problem is there are no dimensions given. So we're just going to use a variable r to stand for the radius. We don't know what it is, but we know that if this is the radius of the circle, then it takes 4 radii to make up this width. So this width of the rectangle is 4r. And going across this way, we have 1, 2, 3, 4, 5, 6 radii to make up the length. So now we can get somewhere. The desired area divided by the total area again. The desired area is the rectangle minus the area of 6 of these circles. That's not the number 60, that's 6 circles. All divided by the total area again. So it's length times width minus 6 times pi r squared divided by length times width. Sub in the numbers, and we end up with this expression right here. Notice that 6 pi is really a number, and I'm going to find out what that is. So these are like terms, by the way, because they're both r squared. So 24 minus 6 pi gives me 5.15. So really it's 5.15 r squared divided by 24 r squared. The r squareds cancel out, and 5.15 divided by 24 is 0.215. So ladies and gentlemen, this is the probability of aiming into these spaces between the cans. Good luck to you.